So after this subchapter on electrolytes, you should be able to do three things. One is define and give examples of electrolytes. You should be able to distinguish between the physical and chemical changes that accompany dissolution of electrolytes. And you should also be able to relate the strength to the solute-solvent interactions that we talked about in the previous video. So electrolytes are simply solutes that, when dissolved in water, produce ions. Common example of that is salt in water. Salt here, KCl, as a solid that dissociates in water to form potassium ion and chloride ion. So KCl is considered an electrolyte. Solutes that do not dissociate into ions are called non-electrolytes. When the dissolution process, like the case of KCl dissolving in water, is 100% efficient, meaning all of that KCl is 100% converted into ions, then we call that a strong electrolyte. That's represented by this middle picture here. And of course, when we have more ions dissolved in water, it can conduct more electricity. So we say that solution that has a strong electrolyte has also high conductivity. And so you would see the lighting of that bulb. If we have something with low conductivity, that means we have a weak electrolyte. An example of that is acetic acid, which is this molecule, CH3CO2H. That can break apart in water to form CH3CO2- plus H+, but this happens about 1% of it. And so there's not many ions in the resulting solution, which is depicted in the cartoon. We consider that a weak electrolyte. And then some molecules don't dissociate at all. They may dissolve, as in the case of ethanol dissolved in water. We know that to be true. You can buy vodka, which is 40% ethanol dissolved in water. But the molecules don't break apart into ions. And so we would call this a non-electrolyte example.